Okay, this video lesson is going to be about simplifying rational expressions. This topic will come up a lot in a lot of the problems you'll be given in algebra, especially in exams, because sometimes they'll try to throw in an extra variable or something that can be taken out over the terms, and you'll have to recognize that before you can actually solve the problem. So this is a good place for us to start, because it's very similar to when we were younger in grade school learning to simplify regular fractions, where you look for common things to make just a regular arithmetic type math fraction smaller. So it's a very similar concept, so it's a good bridging point between arithmetic and algebra. So let's start here, and there's several properties that we'll make use of in simplifying rational expressions. The first one that normally comes up is looking for a common factor. So I'm going to start there and talk about that and give an example, and then I'll move on and mention the other properties that we'll make use of. Okay, I'm just going to write an example and we'll go through it together, and I'll describe what I'm doing as I go through it. Let's say you're given a rational expression that was, say, 4. Sorry about that. I forgot to set my tool back to draw. Okay, now we're ready. So let's say it was 4x squared divided by 2x. So let's say you were given that expression on an exam and asked to simplify it. Well, first of all, a rational expression really is nothing more than a fraction that involves both not only numbers, as we're used to in fractions, but variables, or terms made up of variables, as we'll see in a moment. That can come into play as well. So let's say we were given this, and where would we start? Well, we'd first do just like we did in grade school and look for something that the numerator, which is this top part, the numerator is just like in a regular fraction. I'll circle the numerator in, let's say, red. Sorry. And I'll circle the denominator, or the bottom part, in green. When I say numerator and denominator, just to refresh our memory, that's all the way back to grade school, regular fractions. Numerator is the top, denominator is the bottom. So that's all I'm referring to. Let's say we wanted to simplify this. What would we do? Well, we'd first normally look for something they have in common. And I see 4 in the top and 2 in the bottom. Well, I know that 4 can be divided by 2 times, or that 4 is nothing more than 2 times 2. So let me write that out. Let me replace 4, which is 2 times 2. And these little dots just mean multiplication. You see that a lot in math subjects such as algebra. You'll also see it written, multiplication written in the way the original problem here is written, where they'll just have, like, for example, 2x, which means 2 times x, or 2 multiplied with x. In algebra and other similar topics like calculus, they won't bother if it's a single number and a single variable, or a term made up of variables. They won't bother with the multiplication symbol. They'll just write them together, and by default that means multiplication. So if you see a number beside a variable, they're being multiplied together, just so you know. Okay, so back to our little problem. In the top, just like I saw 4 over the 2 and recognized that 4 is nothing more than 2 times 2, I can do the same thing with the variable. X squared is nothing more than x times x. Anything squared is nothing more than, says it's being multiplied with itself. That's all that it says. And the fact that x is a variable and we don't really know yet, what x stands for, really doesn't matter in this particular case. All we care about is what we can do with x. It could be y, it could be a little baseball picture, it doesn't really matter. X squared is nothing more than x times itself, so we can rewrite it this way. So now that we've written it all out, we can see two things that we can simplify. And I'm going to put the little dot here just because what we're doing right now, it keeps it more symmetric with what I'm doing up top. Well, I have 2 over 2, and anything over itself is 1. I can mark through those because this is nothing more than 1. Likewise, I have x over x. Well, I can mark through those because x over x is 1. And that sometimes is a little confusing to people. You know, they think, how can I say x over x is 1? I don't know how much x is. It doesn't matter. Let's say I said x equals 4, and I wanted to do that. I wanted to say x over x. Well, I now know x over x is 4 over 4, and 4 over 4 is 1. Well, it really doesn't matter what the value of x is. Let's say I changed it, and now I said x is 3. Well, still holds. X over x, now 3 over 3, which is still 1. So just like two numbers over themselves gives you 1, a variable over itself gives you 1. That sometimes confuses people, so I wanted to explicitly state that. Then we'll come down here, we'll have some white space and continue. So now, that goes away, that's just 1, that goes away, that's just 1. What am I left with? I have a 2 at the top in the numerator, and I have an x at the top. And the bottom, just for completeness sake, since we've been referring to the denominator up till now, right now, all I have is 1. And this is something I want to point out. Sometimes people get confused when we're doing a simplification problem like this, and they think, wait a second, everything in the bottom went away, what do I do? You know, they're tempted to say it's 0. Well, it's not. What's really going on here is, you can think about it this way, is you know how a while ago we were going through over on the left and we were factoring out 4s, 2 times 2 and things like that. When I say, I'll write it here, I have some white space. When I say that 3 over 3 is 1, I could also say that it's 1 over 1, and that might help you out. Because really all I'm doing is I'm saying, in the top I have 3, and the bottom has 3. If I divide the top by 3, that leaves me with 1, and if I divide the bottom by 3, that leaves me with 1. And 1 over itself is just 1, just like 3 over 3 is 1. So in a problem like this, it would help you to say, instead of just 1, it might help to say that it's 1 over 1, or that you can reduce it to that. And then the little 1s get multiplied with the 2 and the x in the top, and they have no effect. And in the bottom, they just reduce to the 1 that you see. I know I went through that quickly, but if you think about it, I think it makes sense. And so this can reduce to just what's in the top. Anytime you have a fraction where the only thing in the bottom is 1, you really don't have a fraction. You're really saying the only, that the bottom is not really tearing apart, and that only what's in the numerator is of significance. So really, we're just left with 2x. And that's the final answer for this particular example. And I've dropped the little dot because in a final problem in a topic such as algebra, when there's no need to have a significant symbol for multiplication, you would normally be expected just to write it as the number times a variable, or in this case, 2x. I'll now go to the next topic, which is addition property for simplifying rational expressions.